List of integrated circuit packaging types. Integrated circuits are put into protective packages to allow easy handling and assembly onto printed circuit boards and to protect the devices from damage. A very large number of different types of package exist. Some package types have standardized dimensions and tolerances and are registered with trade industry associations such as JEDEC and Pro Electron. Other types are proprietary designations that may be made by only one or two manufacturers. Integrated circuit packaging is the last assembly process before testing and shipping devices to customers. Occasionally, specially processed integrated circuit dies are prepared for direct connections to a substrate without an intermediate header or carrier. In flip chip systems, the IC is connected by solder bumps to a substrate. In beam lead technology, the metallized pads that would be used for wire bonding connections in a conventional chip are thickened and extended to allow external connections to the circuit. Assemblies using bare chips have additional packaging or filling with epoxy to protect the devices from moisture. Through-hole packages. Through-hole technology uses holes drilled through the PCB for mounting the components. The component has leads that are soldered to pads on the PCB to electrically and mechanically connect them to the PCB. Surface mount. Chip on board is a packaging technique that directly connects a die to a PCB without an interposer or lead frame. Chip carrier. A chip carrier is a rectangular package with contacts on all four edges. Leaded chip carriers have metal leads wrapped around the edge of the package in the shape of a letter J. Leadless chip carriers have metal pads on the edges. Chip carrier packages may be made of ceramic or plastic and are usually secured to a printed circuit board by soldering, though sockets can be used for testing. Thin grid arrays. Flat packages. Small outline packages. Chip scale packages. Ball grid array. Ball grid array BGA uses the underside of the package to place pads with balls of solder in grid pattern as connections to PCB. Transistor, diode, small pin count IC packages. MELF, metal electrode leadless face usually for resistors and diodes. SOD, small outline diode. SOT, small outline transistor, also SO-T-23, SO-T-223, SO-T-323. 2 Roman 20, wide range of small pin count packages often used for discrete parts like transistors or diodes. T-3, panel mount with leads. T-5, metal can package with radial leads. T-18, metal can package with radial leads. T-39, T-46, T-66, similar shape to the T-3 but smaller. T-92, plastic encapsulated package with 3 leads. T-99, metal can package with 8 radial leads. T-100, T-126, plastic encapsulated package with 3 leads and a hole for mounting on a heat sink. T-220, through-hole plastic package with a usually metal heat sink tab and 3 leads. T-226, T-247, plastic encapsulated package with 3 leads and a hole for mounting on a heat sink. T-251, also called a pack, SMT package similar to the D-pack, but with longer leads for SMT or TH mounting. T-252, also called SO-T428 D-pack, SMT package similar to the D-pack but smaller. T-262, also called I2PAK, SMT package similar to the D2PAK but with longer leads for SMT or TH mounting. T-263, also called D2PAK, SMT package similar to the T-220 without the extended tab and mounting hole. T-274, also called Superminus, 247, SMT package similar to the T-247 without the mounting hole. Dimension reference. Surface mount C, E, E, E. Clearance between IC body and PCBH. Total height T. Lead thickness L. Total carrier length LW. Lead width LL. Lead length P. Pitch. Through hole C, E, E, E. Clearance between IC body and board H, 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 board H. Total height T, lead thickness L. Total carrier length LW, lead width LL, lead length P, pitch WB, IC body width WL, lead to lead width. Package dimensions. All measurements below are given in mm. To convert mm to mils, divide mm by 0.254, i.e. 2.54 mm/0.254 equals 100 mil. C, E, E, E. Clearance between package body and PCB H, 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 PBH, H, EBH, BH, H, BH, 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 BH. Height of package from pin tip to top of package. T. Thickness of pin. L. Length of package body only. LW, 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 pin width. LL. Pin length from package to pin tip. P. Pin pitch distance between conductors to the PCB. WB. Width of the package body only. WL. Length from pin tip to pin tip on the opposite side. Dual row, quad rows. LGA, LGA, LGA. Multi-chip packages. A variety of techniques for interconnecting several chips within a single package have been proposed and researched. CP system in package. COP package on package. 3D SiC, monolithic 3D IC, and other three-dimensional integrated circuits. Multi-chip module. WSI wafer scale integration. Proximity communication. By terminal count. Surface mount components are usually smaller than their counterparts with leads, and are designed to be handled by machines rather than by humans. The electronics industry has standardized package shapes and sizes. The leading standardization body is JEDEC. The codes given in the chart below usually tell the length and width of the components in tenths of millimeters or hundredths of inches. For example, a metric 2520 component is 2.5 mm by 2.0 mm, which corresponds roughly to 0.10 inches by 0.8 inches. Hence, imperial size is 1008. Exceptions occur for imperial in the two smallest rectangular passive sizes. The metric codes still represent the dimensions in mm, even though the imperial size codes are no longer aligned. Problematically, some manufacturers are developing metric 201 components with dimensions of 0.25 mm x 0.125 mm 0.98 in x 0.49 in, but the imperial 1005 name is already being used for the 0.4 mm x 0.2 mm 0.1. These increasingly small sizes, especially 201 and 1005, can sometimes be a challenge from a manufacturability or reliability perspective. Two terminal packages. Rectangular passive components, mostly resistors and capacitors. Tantalum capacitors. Aluminum capacitors. Small outline diode SOD. Metal electrode leadless face MELF. Mostly resistors and diodes, barrel-shaped components. Dimensions do not match those of rectangular references for identical codes. D-214, commonly used for rectifier, Schottky, and other diodes. 3 and 4 terminal packages. Small outline transistor SOT. Other. DPAC T-252, so T-428 discrete packaging. Developed by Motorola to house higher powered devices. Comes in 3 or 5 terminal versions. D2PAK T-263, so T-404, bigger than the DPAC, basically a surface mount equivalent of the T-120 through-hole package. Comes in 3, 5, 6, 7, 8 or 9 terminal versions. D3PAK T-268, even larger than D2PAK. 5 and 6 terminal packages. Small outline transistor SOT. Packages with more than 6 terminals. Joule in line. Flat pack was one of the earliest surface-mounted packages. Small outline integrated circuit SOIC, joule in line, 8 or more pins, gull wing lead form, pin spacing 1.27 mm. Small outline package. J-leaded SOJ, the same as SOIC except J-leaded. Thin small outline package SOP, thinner than SOIC, with smaller pin spacing of 0.5 mm. Shrink small outline package SOP, pin spacing of 0.65 mm, sometimes 0.635 mm, or in some cases 0.8 mm. Thin shrink small outline package TSOP. Quarter size small outline package QSOP, with pin spacing of 0.635 mm. Very small outline package VSOP, even smaller than QSOP, 0.4, 0.5, or 0.65 mm pin spacing. Joule flat no lead DFN, smaller footprint than leaded equivalent. Quad in line. Quad in line. Plastic leaded chip carrier PLCC square, J lead, pin spacing 1.27 mm. Quad flat package QFP, various sizes, with pins on all 4 sides. Low profile quad flat package LQFP, 1.4 mm high, varying sized and pins on all 4 sides. Plastic quad flat pack PQFP, a square with pins on all 4 sides, 44 or more pins. Ceramic quad flat pack CQFP, similar to PQFP or to PQFP. Metric quad flat pack MQFP, a QFP package with metric pin distribution. Thin quad flat pack TQFP, a thinner version of LQFP. Quad flat no lead QFN, smaller footprint than leaded equivalent. Leadless chip carrier LCC, contacts are recessed vertically to wick in solder. Common in aviation electronics because of robustness to mechanical vibration. Micro lead frame package MLP, MLF with a 0.5 mm contact pitch, no leads same as QFN. Power quad flat no lead PQFN, with exposed die pads for heat sinking. Grid arrays. Grid arrays. Ball grid array BGA, a square or rectangular array of solder balls on one surface. Ball spacing typically 1.27 mm 0.50 in. Fine pitch ball grid array FBGA, a square or rectangular array of solder balls on one surface. Low profile fine pitch ball grid array LFBGA, a square or rectangular array of solder balls on one surface. Ball spacing typically 0.8 mm, 8 mm. Micro ball grid array MBGA, ball spacing less than 1 mm and 1 mm, less than 1 mm. Thin fine pitch ball grid array TFBGA, a square or rectangular array of solder balls on one surface. Ball spacing typically 0.5 mm, 5 mm. Land grid array LGA, an array of bare lands only. Similar to in appearance to QFN, but mating is by spring pins within a socket rather than solder. Column grid array CGA, a circuit package in which the input and output points are high-temperature solder cylinders or columns arranged in a grid pattern. Ceramic column grid array CCGA, a circuit package in which the input and output points are high-temperature solder cylinders or columns arranged in a grid pattern. The body of the component is ceramic. Leadless package LLP, a package with metric pin distribution 0.5 mm pitch. Non-packaged devices. Although surface mount, these devices require specific process for assembly. Chip-on-board COB, a bare silicon chip, that is usually an integrated circuit, is supplied without a package, which is usually a lead frame overmolded with epoxy and is attached, often with epoxy, directly to a circuit board. The chip is then wire bonded and protected from mechanical damage and contamination by an epoxy glob top. Chip-on-flex COF, a variation of COB where a chip is mounted directly to a flex circuit. Tape automated bonding process is also a chip-on-flex process as well. Chip-on-glass COG, a variation of COB where a chip, typically a liquid crystal, display LCD controller is mounted directly on glass. Chip-on-wire COW, a variation of COB where a chip, typically a LED or RFID chip, is mounted directly on wire, thus making it a very thin and flexible wire. Such wire may then be covered with cotton, glass, or other materials to make into smart textiles or electronic textiles. There are often subtle variations in package details from manufacturer to manufacturer, and even though standard designations are used, designers need to confirm dimensions when laying out printed circuit boards.